Hello everyone, welcome to Embedded Systems course with Arduino. In last session, we had interfaced a servo motor to Arduino and saw that how we could control the angles to rotate the servo motor by connecting it through an Arduino pin to the control pin of the servo motor and providing the respective angles, and we were able to rotate it clockwise and anti-clockwise directions, right? In today's session, we are also going to introduce or interface the servo motor to Arduino, but there will be a slight change that we will interface the servo motor to Arduino through a potentiometer, right? So the only change is that in addition to components which we last used, which were Arduino Uno R3, and we used a servo motor, right, which we saw as micro servo in the Tinkercad, and we used a breadboard, right, and we controlled the angles uh, through an Arduino pin, right, providing the angles using the servo library and writing that angles to the control pin of the servo motor. Today we are going to control the angles of the servo meter through a potentiometer, right? So potentiometer, I know most of you would have heard, is what? Variable resistance, right? It's variable resistance where you can vary the resistance and correspondingly the output voltage can change. Now in this session I want to first go over the working of potentiometer, how it works, and then we are going to Tinkercad and connecting the servo motor to Arduino through a potentiometer. So potentiometer in general has three poles, right? First is this VCC, you connect a 5 volt here, right? You connect the ground to 0 volt, and this is the output, right? So output is what? So output will be certain voltage, right? Now how this voltage is calculated, right? So you see that once you rotate, right, once you rotate in this direction, you are seeing that the angles are changing, right? And once the angles are changing, the resistances are also changing. Now this actually is total is 270 degree, you see here, right? So now what particular 1 degree and the control pins and the you if you see here the power pins, the total supply can be of 5 volts, right? So what does every degree correspond to can be calculated using this. Whatever angle you are rotating to, if you see here, the angle will start changing from 0 to 45 to 90, and accordingly that will be divided by 270 degree, right? This is the max angle, right? This is the max angle the potentiometer can rotate, right? And you are dividing that the moved angle by the total max angle and multiplying by 5 volts, right, to get what is the output voltage, right? And you will get here the output voltage. But what we do with this output voltage, right? So what we can do is, now this output voltage, right, can be mapped to a degree. We have to map this output voltage to degrees, right? We have to map this output voltage to degree of rotation for the servo motor, right? So what we do is we provide these voltages, right? We provide these voltages to the analog pin of Arduino, right? You provide this to the analog pin. Let's say you provide this to analog pin A0, right? And we know that analog pins have values, right? They can map to 0 to from 0 to 1023. These integer values they can map, right? So they will map the voltage. They will map the voltage to this integer values, right? So they will map your voltage to certain integer value, and this integer values we can correspondingly map to the degree of rotation. Okay, so you provide a certain output voltage by changing the potentiometer, by rotating the potentiometer, by changing the resistance, right? you are changing the resistance here, right? This is the variable resistance. You provide the output voltage. That output voltage we take in the analog pin. The analog pin provides a reference integer, and that integer we will map it to the degree of rotation. Okay, so in this way we will provide the degree of rotation and create a servo object for the code and provide that angle to the right inbuilt function of the servo object. So this is in general the functioning of potentiometer. Now we will go over Tinkercad and start connecting the servo to the Arduino through a potentiometer. Okay, let's go over to Tinkercad. So I have just taken the old circuit, but the only difference here, the last session circuit only, but the only difference is if you select a search a potentiometer, right, you will get this, and you can drag and drop this here, right? So potentiometer has 3 pins, as I showed you, terminal 1 and terminal 2. So once we have one terminal we have connected to ground, the other terminal we have connected to power supply 5 volts. So this rotation can only provide you maximum of 5 volts, and the angle of rotation will tell you what is the output voltage. So let's take that output voltage on this wiper pin, right? And we said that we will connect it to the analog pin of the Arduino to get a reference integer, right, in between 0 to 1023, and that reference integer we will map to a degree value which will be provided to the servo motor to rotate, right? So this is in general the logic. So our connections are done. It's very simple. We have taken a potentiometer, 3 terminals, right? Terminal 1 and terminal 2 are power terminals, ground and 5 volts, and the wiper terminal, right, is the output voltage which we are connecting to the analog pin. So we will read the analog pin, right, to get the value and provide that value to servo motor through the digital pin 9, right, and ask the servo motor to rotate, right? So let's go over the code once, right? The code almost remains the same. We included a library servo.h, right? Then we created an object of servo type which is named as servo1. We took a local variable angle which we will provide to the servo, right, to rotate to that angle. Now one time initializations, we are attaching the servo to pin 9 of the Arduino. So servo.attach, so that this will pass a PWM signal and the servo can work, right? Now let's go over to the actual task loop, right? We want to keep reading the potentiometer, get a reference integer, map that reference integer to a angle, and provide that angle to the servo motor. This is a repeated task. So what I do is, right, so this analog read function, right, this is the comment. So analog read function we use to read the analog value from the pin A0. Because our wiper is now connected to A0, the output voltage will go to pin A0, the analog pin A0. So we use this analog read function, right, and get it in the value of a potentiometer value, pot value we have named it. Now what we do, so this I told you that the output voltage will map to certain integer, because whatever 4.5, 3.2, what that will map to certain integer between 0 to 1023, right? So whatever the value you are getting, we are mapping to 0 to 1023, and that 0 to 1023 is mapped to 0 to 180 degrees, right? We will, for every certain value, certain integer, we are mapping to a degree, right? So that is in the angle, right? To convert, so what does map function do? It is converting the analog, right, potentiometer value, the output voltage value, to ranging from 0 to 1023. We got this pot value from the A0 pin. It's an integer, right? The output voltage was provided by the potentiometer, that it will convert, right? The analog pin will convert this value 0 to 1023, right, to a desired servo angle range of 0 to 180 degrees, right? So we took the voltage, provided it to the analog A0 pin. That analog A0 pin will map this 0 to 1023 integer value corresponding to a certain voltage which came it as an output, right, from the potentiometer to the servo angle. Now similarly, same functions, the servo one object, we write the angle to it and delay it by 15 milliseconds, so that 15 milliseconds it takes time to reach that angle, right? So the only difference here was that earlier we were attaching the pin and just providing that the value, right, the angle value, right, through the servo, right. We were turning 0 to 180 degree, right, and 180 degree to 0. So we are providing that uh, through simple tasks, right, servo dot write in build task. Now we want to read the potentiometer, how much we rotate, how much resistance we change, and accordingly we want to rotate the potentiometer, right. We want to have a manual control. So that is what we have done. We have taken this potentiometer getting the output voltage, right, the output voltage it will provide, and then we are mapping to an analog pin, right, which is the A0 pin, right. The analog A0 pin will can map that particular voltage value in between 0 to 1023. That 1023 will be mapped to certain degrees, and that degree will be provided to the servo, right. So now let's start the simulation, right. So now it is at 0, right. So now I will rotate this. You can see at the potentiometer I am rotating this, and the servo motor is rotating, right. Why servo motor is rotating? Because you are providing an output voltage, variable output voltage, through the wiper to the analog pin. The corresponding integer mapping is changing and the corresponding degree is changing, right. I rotated max and it rotated 180 degrees, right. I am rotating it back, right, 90s, right. Now see, it has come to 90, right. Another half I will rotate, it will come back to 0, right. So this is what how the potentiometer works, right. You have now a manual control. You are rotating the potentiometer, changing the variable resistance, thereby changing the variable voltage. The analog pin is reading it, mapping it to a corresponding integer, right, was between 0 to 1023 levels, right, and then that integer value is getting mapped to a degree, right. We saw here by this code, right, and that degree is getting provided to the servo object, the servo one, which is controlling this servo motor, right, through the pin 9. So this is what we are doing in this code, and that is how you can control a servo motor through a potentiometer, right. You have a manual control on this, right. So in this session, in the last session we had directly connected the servo motor. In this session we connected the servo motor through potentiometer, right. So in next sessions we'll integrate more peripherals. Thanks for joining.